In this video, we're going to look at a graph of a polar equation, and we're going to graph it by hand, and then you can go ahead and check it on your calculator after we do that. But let's take a look at r equals -4 sine theta, and we're going to start with this chart to give us some values. When you're graphing these by hand, sometimes the values you use in the chart are going to be arbitrary until you get an idea of the pattern of the graph. So let's go ahead and substitute in these values for theta into our function. So when theta is 0, sine of theta is going to be 0, so we have -4 times 0, which is 0. When we plug in pi over 6, we're going to have -4 times 1/2, so that's going to be -2. When I substitute in pi over 3, I'm going to have -4 times √3 over 2. That's going to be approximately -3.5. Pi over 2, that's going to be -4 times 1, or just -4. And then 2 pi over 3, so now we're over in the second quadrant. So the sign is still going to be positive, -4 times √3 over 2 again. So that's going to be about -3.5. And for 5 pi over 6, -4 times 1/2, or -2. So you can see there's some symmetry here. And then the last one, sine of pi is 0, so -4 times 0 is going to be 0. All right, so let's go ahead and graph these polar coordinates. So we've got 0, 0 first. Then we've got -2 pi over 6. So I'm going to go out to the second circle on the left. And then I'm going to rotate pi over 6 radians. So that's going to put me right down here. Then I've got -3.5, which is just an approximation, so -3.5 around here. And then I'm going to rotate pi over 3 radians, which is going to put me down here. Then I've got -4 pi over 2. So go out to the fourth circle and then rotate pi over 2, which puts me down here at 3 pi over 2. And -3.5 again. And I'm going to rotate 2 pi over 3 this time. So now I'm going to rotate all the way over to here. If I'm rotating 2 pi over 3 from the left side, from pi already, I'll end up at 5 pi over 3. Then I've got -2 and 5 pi over 6. So if I'm rotating 5 pi over 6, that's going to land me right here. And then -4, 0 again puts me right back at the origin. So now we'll just connect these with a nice smooth curve. See what we've got here. So if you did an accurate job of plotting your points, you should have something that looks like a circle. All right, and before we end the video, let's take a look at converting this into a rectangular equation. So if I have r equals -4 sine theta, one of our techniques is to multiply both sides by r. On the left, I'll have r squared. On the right, I'll have -4 r sine theta. We know that r squared is going to be x squared plus y squared. And I know that r sine theta is y, so on the right side we have -4y. Let's bring everything over to the left side. So I have x squared plus 4y. I'm going to complete the square, plus y squared plus 4y. Let's complete the square for the y, so that's going to be plus 4 over 2 squared. Since I added 4 over 2 squared to the left, I've got to add it to the right. So we get x squared plus y plus 2 squared equals 4 and there is our circle. So our center is at 0, -2, which we can see right here. There's our center. If we were in rectangular coordinates, it would be in the same spot. And we have a radius of 2 units. All right, so as always, make sure you get any of your questions answered. And we will see you in the next video.